Today we're going to be talking about another way of displaying data. This way is known as two-way tables. A two-way table displays sizes of subgroups in one larger group based on criteria. So in this two-way table, the larger group is shirt color, and the subgroups are the colors of the shirts, so pink, brown, and blue. The criteria is gender, so whether or not it's a boy or a girl wearing the shirt. Looking at the two-way table, we can see that it's pretty easy to figure out what the table is saying. There's one boy wearing a pink shirt, there are 12 boys wearing brown shirts, etc. And the total amount of boys is 25. So if we go to the right, we see that the amount of boys is 25. Likewise, if we count down, we can say, okay, there's 12 boys wearing blue shirts and there are 13 girls wearing blue shirts. The total amount of people wearing blue shirts, we go down vertically in the column and see that there are 25 total people wearing blue shirts. Every entry in this table, in the white, is a joint frequency. So a joint frequency is just another way of saying an entry in the two-way table. A marginal frequency is the row or the column total. So 25, the total amount of boys, is a marginal frequency. 10, the total amount of people wearing pink shirts, is a marginal frequency. If you look here in this bottom right corner, the total of both the rows and the columns should add to the same thing. There's 25 boys total and 25 girls total, that adds up to 50. And if you add up the total amount of shirt colors, so there's 10 pink shirts, 15 brown, 25 blue, you still get 50. And that means the total amount of people that you surveyed is 50. And this bottom right number should always be the same, adding these marginal frequencies vertically and these marginal frequencies horizontally. They both add up to 50. A relative frequency table happens when you convert the original two-way table to percentages based on the total amount. So if we look at the original table here, and then we look at the relative frequency table below, we can start to see how they've done this. So the most important thing to know is the total amount of data points collected, which you can find by adding these marginal frequencies here. If we know the total amount is 50, we can start on the top left over here by saying, okay, the total amount of boys in pink shirts is 1. If we divide 1 by 50, if we make that into a fraction and divide the top by the bottom, we get 0.02 or 2%. So then we fill in this value here with 2%. Same thing goes for girls in pink shirts. So we put 9, divide it by the total amount, 50, and we get 0.18 or 18%. So here you can see that's where we got the 18%. So then you would continue to do that for the rest of the joint frequencies in the table, so these values in the white. To find the marginal frequencies, we can add horizontally, so from left to right. Boys make up 50% of the data points, then we add left to right again, girls make up 50% of data points, and of course, 50 plus 50 equals 100. If you've gotten like 102%, you've done something wrong. The total amount should represent 100% of the data points. Then if we add vertically, we can see that 20% of the people are wearing pink shirts, so 2 plus 18, and so on and so forth. And these marginal frequencies added horizontally should again add up to 100%. So the last thing we can talk about is conditional relative frequency, which is finding the percentages of the table based on the columns only. So in this conditional relative frequency table, we do not find the marginal frequencies. So what this is telling us is we now find the totals for each column, the columns only, so there's 10 total people wearing pink, 15 people wearing brown, 25 people wearing blue. Then what we do is we convert that into percentages based on the column. So we take 1, divide it by the total, which is 10, and we get 10%. We do the same thing with 9. So 9 out of 10, 9 divided by 10 is 90%, and we do that for each column. Each column should add up to 100%, and we do not bother with marginal frequencies. So what the conditional relative frequency tells us is out of people wearing pink, we can say that 10% are boys and 90% are girls. So this gives us more specific information based on the column or the subgroup.